Hello there, I'm Thomas Hatsios, a German-American pilot flying the Boeing 787-900 to 95 from Zurich International Airport, gonna be from Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an ILS localizer landing. So now I'm in the cockpit for the takeoff for preparation of the quality wings. Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start setting the cockpit instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display. The displays the airspace indicator, the airspace selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot, flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in terms hundreds and thousands feet per minute, all the steepness of the trigonometric angles in decrease, you can climb the descent. Also we have the altitude indicator with the pitch ladder decrease and the bank angle increase, the artificial horizon. We have the ILS localizer, so we have the runways we're gonna use for takeoff and for landing, and we have the runways antennas of the threshold runways antennas that transmit the radio frequency. It's unique for each runway, runway heading and runway frequency. So we have the runway 14 in the Zurich International Airport, Lszh airport. Over here you can see this runway for takeoff and for landing. So we have the ILS localizer tuned with this radio frequency. We're gonna tune also the magnetic north pole heading of the autopilot director system panel. So we're gonna be aligned with the runway heading like this for landing and for takeoff. And we have also the ILS localizer. We have the vertical glide slope of the ILS localizer and also the horizontal localizer, the ILS localizer crossbus, and also the flight director crossbus for manual guidance of the aircraft, and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode dynamic zero with the autopilot and the autopilot later on vertical navigation mode. We have also the HSI that displays the horizontal situation indicator, the magnetic heading and track, and also the integrated flight plan display. You can see the flight plan. We're gonna create a layer using the flight maps computer, so we're gonna be having all the waypoints one by one. They're gonna be connected with the flight plan line as we're gonna be flying. We have also terrain and weather reflections from the weather radar. You can see the terrain map displayed in the navigation display with red, green, and yellow amber indication. So you can see the lakes, rivers, and the sea also with blue, and also you can see in the terrain map we have the magnetic north pole and the geographic north pole and magnetic variation depending on where we are in the world. You can see also so in the terrain map we have the airports displayed with a blue color with a 4-letter ICAO name. It's airport, our own airport. You can see the runways you're gonna use both for takeoff and for landing. Also we have the runway length, the runway heading, and also the taxiways using the GPS receiver. And also we have the air data computer over here with the inertial reference system for alignment, GPS receivers, magnetic and geographic north pole, pitot static and pitot dynamic, the airspeed and the altitude over here of the aircraft from the air data computer, and also the laser gyroscopes for gyroscopic acceleration and deceleration display of the altitude of the aircraft in flight. So we have the terrain and weather reflections over here, the terrain map. You can see red, green, and amber indication. The airports you can see here is Germany, France, and Switzerland. Down here the Swiss Alps. You can see also the elevation. The aircraft can fly over here above the ground level, thousands of feet of terrain, and the distance in nautical miles like 0.48 nautical miles. Also we have 80 nautical miles set for the range over here. The range, the plan, menu, map, weather radar, terrain, traffic, and also minimum barometric setting over here. Accept, cancel, reject some warnings. So we set the barometric altitude over here of the aircraft, the baro setting. So you can see the barometric setting altitude, radio, and barometric altitude, inches of mercury to 9.92. We can set also 1000, it's right now 29.92 inches of mercury, or hectopascals either side. And standard. We have also other displays to show you later as we go on before a flight. So we have also to see here, you can see the airspeed indicated from the pitot dynamic and also the altitude, pitot static and pitot dynamic tubes, vertical rated climb descent, pitch attitude 2.5, 5, 7.5, 10, 12.5, 15, 17.5 to degrees, pitch up and pitch down. The radio altitude above the ground level, you can see like 2,500 feet above the ground, and also the bank turns in flight over here. You can see the bank rolls like 5, 10, 20, 30, 45 degrees in the left and right, pitch up, pitch down, bank rolls, and also the vertical rate of climb descent. The airspeed very important. Also the HSI, magnetic heading and track, GPS and ADS over here connected. So we have now the map mode, we have the engine source indication, DN1. I'm gonna show you right now in a couple of minutes the indications of the engines. Using the thrust levers here, you can see increase and decrease. You will see the engines increase over here or decrease in power setting and thrust commanded. So we're not configured right now for takeoff. So it gave us a warning. We have also the flight management computer, very important to set up the flight plan of the aircraft, and also horizontal and vertical flight plan, the takeoff weight and center of gravity, horizontal trim stabilizer. I will show you the horizontal trim of the aircraft over here, the flight controls. So we'll set also the horizontal trim stabilizer. So I'll show you now the flight controls of the Boeing 787. You can see here, so here we have the flight controls. We can climb and descend the aircraft like this. So this way you climb, this way you descend. You use I hope you have a better view. Maybe a little bit more lighting, so this is better view right now. So you can see we can climb. I have the side stick, the Lszh Extreme 3D, which is the Airbus identical side stick you can use for climb descent, and also make left turns, right turns, side stick left and right. This is the control wheel of the Boeing 787. In the yoke of the Boeing 787, the control column, you can make climbs and descent, pull the elevator up and down. Also the rudder pedals, which are also interconnected with the nose wheel steering, the tiller over here. So you can use the nose wheel steering also to control the aircraft, and also have the vertical stabilizer. You have the toe brakes also over here. So I will show you also the outside view of the aircraft, showing you the flight controls of the Boeing 787. I will show you the outside view of the aircraft and talk to you about the Newton's physics, aeronautical and airspace engineering, and derive some principles we need to know for the aerodynamics, Newton's physics and the new theory of fluids, aerodynamics for the air transport pilot license, the commercial pilot license. So you'll see now in the outside view over here, you can see the surface area of the wings hold the weight of the aircraft as we fly over here. The main aerodynamic cord is where the maximum aerodynamic lift occurs, and the forward wings is also the position where the center of pressure moves back and forth. Also the stall, the airflow becomes detached over here from the top surface of the wings, and the flow of the air becomes, we have the stall of the wings in the air when we fly. So we need to pay attention here in the display. You see the primary flight display where we have the airspeed indicated in the airspeed tape. We have also the stall speed displayed with a number and rate indication, so we need to avoid the stall when we fly. We press the yoke down or the side stick. If we are in the Airbus aircraft, we have the side stick instead of the yoke to control. So all controls the same, and then apply some thrust as needed. So we have also in the outside view continue the aerodynamics. You have the aerodynamic cord, where is also the center of gravity. We have the yawing over here axis. So you can see we have the left and the right wing fuel tank, the center tank. We have 30% right now in the left and the right wing, 10% in the center tank. We have also the high, the the engines, the turbofan engines, the vectors that push the aircraft forward. You can see the exhaust gas here from the cone, and also from the bypass of the engines, the high pressure compressor and turbine, and the low pressure compressor and turbine in the front, and the front fan, the combustion chamber. So you have the jet blast that moves the aircraft forwards, left and right engine, thrust vectors like this. So we have over here where the main aerodynamic core is, the center of gravity is the yawing axis. We can yaw the aircraft left and right using the rudder pedals. So you can use the rudder in the air, in the ground. Mostly we have both the nozzle and the rudder interconnected. So you can see the nozzle, we can deflect that from 0 to 45 knots, or like 76 degrees left and right deflection for the nozzle steering. Then at 45 nautical miles per hour, about 70 kilometers an hour, we have the rudder is aerodynamically effective enough, so we have more control as we go with the rudder above 70 kilometers an hour. So the nozzle steering is decreasing to like 70.6 from 76. Then as we go to like 80 nautical miles per hour in takeoff or inverse in landing, we have the rudder only aerodynamically effective, and the nozzle steering is deflected at 0 position. It's locked at 0 position, so there is no nozzle steering above 140 kilometers an hour, 80 nautical miles per hour, both takeoff and landing. So we have on the rudder aerodynamically effective. So the rudder here is, you can see the rudder pedals left and right rudder pedals input over here. So you have the left and the right input over here for the nozzle steering and the rudder. So we have one more axis here, is the lateral axis from wingtip to wingtip. We can pitch the aircraft up and down for climb descent like this using the wingtip. The pitch axis over here from wingtip to wingtip transverses the other axis, so we climb with descent using the side stick in the Airbus or the yoke in the Boeing like this. So you descend and you climb. So you have also the horizontal elevator trim, or some aircraft have this one has the elevator trim, other have the horizontal stabilizer trim. The stabilizer trim is streamable. So we have here, you can see the elevator for climb descent, side stick back and forth in the Airbus, control column back and forth in the Boeing. Both sides are interconnected in the Boeing aircraft, all flight controls together, unless you have a failure. Also we have one more axis besides the pitch axis and the yaw axis. We have, this is the longitudinal axis from nose to tail, transverses all the other axes, is the side stick left and right in the Airbus aircraft. You make ailerons and spoilers deflect, left and right turns like this. In the Boeing is ailerons, spoilers and flaperons, and also is the control wheel in the Boeing instead of the side stick left and right. So there is no difference between Boeing and aircraft flight controls like this. You have the control wheel in the Boeing for left and right turns, side stick left and right in the Airbus. You have yoke up and down, back and forth in the Boeing, side stick back and forth in the Airbus, rudder pedals, and also nozzle steering, toe brakes. So this is all flight controls we need to know. Also we can see the bottom surface of the wings over here. You can see is more flat, finishing the aerodynamics. So you can see also the wings are, the flaps are extended, so the bottom surface, as we accelerate for takeoff like 250 kilometers an hour or 140 knots, there is higher pressure, the airflow moving slower below the wings, so higher pressure, which pressurizes the aircraft weight and wings up into the air. You can see also the top surface of the wings. We have more curvature, so there is a faster airflow of the air. So there is a lower air pressure, which sucks the aircraft weight and wings up into the air. So this is the differential pressure between the bottom and the top surface of the wings. Also the aerodynamics we need to know for flying the Boeing 787. One last part from the flight controls, horizontal trim stabilizer over here. You can see we have this horizontal trim stabilizer switch down here. So this way you trim the elevator up, this way you trim the elevator down, and this is the nose pitch up, nose pitch down. You have the elevator trim like this. This is the trim switch. Elevator trim, left click down, right click up. So we trim the elevator up and down like this, and we balance the aircraft. So we have also the flight control computers over here, primary flight control computers, normal, alternate, direct mode. Also, as you can see, in the auto position that control also the auto trim function of the Boeing 787s, and this is a fly-by-wire aircraft. We have the auto trim, we have the normal horizontal stabilizer trim here for the elevator as we climb and as we descend the aircraft. Climb, descend, also horizontal stabilizer trim, automatic and manual. So automatic is by its own aircraft control, flight control computers. We have, like in the Airbus, you have the normal, the normal alternated direct modes, like in the Airbus. So in the Airbus you have left and right turns as 2.8 G limited G turns or 67 degrees, and also you have climb 30 degrees or 1.5 G's, and descend minus half G's or minus 15 degrees. So also here you have also here you have in the Airbus aircrafts also you have these controls are degraded sometimes, so you can disconnect them. Also in the Boeing, so you have the normal flight normal elevator trim over here. You can see elevator trim control, so you can read it. Elevator trim, left click down, right click up. Also the flaps speed over here, some other indications. The autopilot disengage over here. This switch autopilot disengage, and the head up declutter. So we need the elevator trim right now. You can see how many degrees you pitch up and pitch down the elevator trim. 4.5 right now. Stabilizer trim, rudder trim, flaps position, gear, landing gear up and down over here. Alternate gear, some other indications. Lock override and some warnings. So we have horizontal trim stabilizer here. Parking brakes also here. Auto brakes actually, not parking brakes. So we're gonna make a few more settings before going into flight. So you can see here we have the alternate pitch trim switch. You can trim alternate the horizontal tail like this, nose up and nose down. So you can see elevator trim, left click down, right click up, nose up and nose down again. We have also the parking brakes on and off over here. We have these stabilizer cutoff switch over here, radio communications over here, VHF, high frequency, satellite coming from proximity with the radar, transporter over here. So this is a radio management panel, radar trim also. So we go back, stabilizer trim. This is the fire extinguisher left and right, pull out and switch, fuel control. Over here I will explain one by one our systems. So we go stabilizer trim, cutoff switches as I told you. We have the auto trim over here, automatic trim from the flight control, primary flight control computers. If you have a failure over here from the hydraulics that affects either left and right elevator or horizontal stabilizer, you will have a malfunction of the flight control computers at the grade in the mode. So we won't have from the autopilot flight director system panel and the auto throttle, and also from the flight management computer inputs, the flight director. We're gonna lose the automatic trim. So we need to come down here in the pedestal of the aircraft where the engines are located. This is for all Boeing aircraft. So you see the engines down here, the pedestal, you see the auto trim, stabilizer, cutoff switch. So you move from normal to cutoff, either the left or the right stabilizer fails or both of them. From normal to cutoff, this is for all Boeing 737, 747, 757, 767, Boeing 777 and Boeing 787 from normal to cutoff this guarded switch. And then you have only the alternate or the manual pitch trim over here. So maybe you have no autopilot, you pitch the elevator, the tail of the aircraft up and down to balance the aircraft, to relieve the air pressures, and also pitch the nose up and down as you fly. So you have all the time the stabilizer here, manual trim. So this is a little bit more hasted up. You see the elevator trim up and down. We have one more view left over here before going to flight. Elevator, also radar control. So this is the flight controls. You can see also the flaps which increase and decrease in position, how many degrees you need flaps over here. This handle can move all the way up, all the way down. You can see how many degrees you set here the flaps position. Like 70, 80, 25, 30 degrees. Also the speed brakes up and down. The engines over here, you can see left and right engine. Fuel control over here, cutoff switch for the left and right engine. Auto throttle disengage, disengage the auto throttle, takeoff ground switch and the thrust reverse. Over here you can pull up the thrust reverse for landing. After touchdown or in our ejected takeoff, flight management computer over here. Very important, set up the flight plan. So we go now. Another view of the flight controls of the Boeing 787. Then I'm gonna show you the flight management computer and make the engine start demonstrations very quickly. So we have not much time tonight for all the systems. So I'm gonna show you also this view of the Boeing 787. It's like beautiful flight controls. Also the Airbus side stick that I'm using. So you can see here I control also the thrust levers for the engines, the horizontal trim stabilizer, the rudder pedals, and the yoke of the Boeing 787, and the control wheel, the controls, all flight controls of the aircraft. So you can see here a beautiful jet aircraft. Thank you for flying with me. You can see we have the Lszh Extreme 3D. So you have here the side stick. One more view of the side stick control. So I'm trying to fix a little bit the view. Now we have better view from the screen. That's what I'm trying now to get. So now I'm gonna show you a nice review of the Boeing 787-900 aircraft, the flight controls system. We make the engine start demonstration. Stay with me until the end part of the video for the complete manual flight of the jet aircraft. So we have here, we can climb the descent. Like this, climb descent, also make turns to the right, make turns to the left. So we have the side stick in the Airbus up and down, the Boeing, the control column up and down. Hope you like it. We have the horizontal trim stabilizer. You can see both sides, the captain and the first officer, are interconnected and moving together in flight in the Boeing aircraft. So climb the descent, make turns left and right, interconnected flight controls. Unless you have a failure, you can move with an override force in the Boeing aircraft. In the Airbus, you have the side stick priority button over here. You take other side priority in the Airbus aircraft. So in the Boeing you use this system. As you can see, we have the thrust control over here. You can move the thrust levers back and forth like this to command the engine's thrust. So you can see the engines moving up or down in the idle. So we climb, descend, make turns to the left, make turns to the right. All flight controls of the Boeing aircraft. Also for the Airbus, as you can see, I have the identical side stick. Also the outside view a bit more. So we climb, descend, use the elevator. We'll climb, descend, rudder pedals over here, rudder, nose wheel string, the forward nose wheel in the ground. Also ailerons and spoilers, left and right turns like this, and horizontal trim stabilizer also have it mapped. So you see aileron, spoilers and flaperons in the Boeing, ailerons and spoilers in the Airbus. So that's the difference. So this is enough for the flight controls right now. Go back into the cockpit, show you the rest of the systems. So now we have enough with the flight controls lessons, and then we'll go very fast for the rest of the systems. So you the flight management computer, autopilot, flight director system panel, engines indications, overhead panel. So maybe we start with the engines indication, then show you the flight management computer. So we have the engines indication here. You can see are controlled by the FAREX N1, which is low speed starters, low pressure compressor turbine of the turbofan, which is engine, the left and right engine, exhaust gas temperature engine, N2, which is the high speed starters, high pressure compressor turbine of the turbofan, which is engine, the left and right, fuel flow principle, 1000 kilograms, 1000 pounds, oil pressure, takeoff 99.2%. Thrust never exceed red and yellow and green, the takeoff setting. Fuel flow principle, 1000 kilograms, 1000 pounds, it's 1000 pounds right now. Oil pressure, oil temperature over here, oil quantity and the vibration of the M2 stage of the engine. flow valves position over here, cabin pressurization that admit pressurizer from the 5th and 9th stage. Where is the N2 stage is the bleeder for the cabin pressurization. We can engine radiation, air conditioning, ventilation. Over here, many systems. So you see many systems. Hydraulic fluid tanks are pressurized from the engine, so from the systems like the APU over here, or rammer turbine. So we have cabin pressurization over here, normal, auto, manual. We have also air conditioning, ventilation, oxygen in wing and engine at the ice over here. So the hydraulic fluid tanks, all flight controls movement you see is from hydraulic fluid actuators in the flight control surfaces. Also we need pressurizer from the engines to make movement, landing gear, external retract, thrust reverser for the engine, the nose wheel, steering, the rudder pedals over here. The rudder, all flight controls need hydraulic fluid pressurization to move. So we have a few more things to know about the engines, about the FAREX. The FAREX are the full authority digital electronic control computers, one installed per engine, gearbox, dual channel redundancy. If one channel fails, the other takes over. Control monitors and displays all the engine data using the upper and lower ACAS, all the multifunction display, engine gear indication equalizer system display, like the N1, which is low speed status of low pressure compression turbine with the turbofan to the engine, exhaust gas temperature for engine, N2, which is the high speed status of high pressure compression turbine with the turbofan to the engine, fuel flow range per 1000 kg, oil pressure, temperature, quantity, and the vibration of the N2 stage of the engine. So we have over here, we're gonna start a few more things. The flight management computer. You can see the setup that I have, the computer over here, and my flight controls. So I have this mousepad control, the flight management computer over here. So I'm gonna start the flight management computer in a couple of seconds. You can see we have the mousepad here. I can use also the inputs from the screen over here, and I have the keyboard, alphanumeric keyboard. So you can see identity, position, performance, takeoff, annunciate status, flight plans. So we have also autopilot flight director system panel. Here is the autopilot engage and disengage switch over here, the airspeed setting over here, auto throttle left and right, engage and disengage flight director, on and off, LNAV, we can set later the LNAV if we make a flight plan, we cannot set yet. So we have also landing aircraft over here. You can see it's coming for landing. So also the flight management computer before going for the autopilot. We're going very fast tonight, so it's coming for landing. We also go for flight management computer over here. Set up the flight plan, control quadrant over here. So you see again the thrust levers, the flaps, speed brakes from the top, fuel control. We have the mouse pad here, and the flight management computer, autopilot here. So we have identity over here, position, performance, takeoff, annunciate status, navigation data, flight plans. The identity, Boeing 787-900 GNX engines, ARAC cycle. Position, reference airport, Lszh airport, and the inertial coordinates can be aligned like this. So we go in with the index, performance here, 0 fuel weight plus fuel on board, gross weight for takeoff, reserve fuel, cruising altitude and cost index, mean fuel temperature, and cruising center of gravity, the route, Lszh over here, back to Lszh, clear the discontinuity, runway 14. So we have departure and arrival over here. We can set runway 14 for departure, runway 10, 16, 2832, either runway select. So we select runway 14 trans Zui, the seeds, these are the range of departure, waypoints and fixes, Zui to Alpha. Departure arrivals over here, so we set the arrivals. We can select VOM 162834 over here, ILS14, ILS16, ILS28, ILS34, GLS14 localizer, 28 localizer 34. So we select ILS14 over here, trans Amiki over here, and trans the stars is other terminal arrival waypoints and fixes, the Negria 1 Alpha. So we have the arrival set. We can look at the route over here, the legs is displayed with blue. First waypoint after takeoff, climb to the Zui 6 nautical miles, climb to the Nigria, make a left turn, then make a right turn, descend approach landing Zurich 701 and the runway over here. So we set initialize 0 fuel weight 322.7 thousand pounds plus fuel 34,300, gross weight 357, reserve 5%, cruising altitude 25,300 and the cost index 100% over here. So we set cruising center of gravity over here, and fuel freezing temperature, the fuel will freeze in flight. So we activate the route over here. First waypoint 136 degrees, 2 nautical miles, make a left turn, 1 nautical 235, 6 nautical is Zui, 301 knots, 6,000 above sea level, Nigria 071 heading, 26 nautical miles, 301 knots over here. knots, flight level 22,200, Mativ, make a right turn for descent, 12 nautical miles from Nigria, 320, 11,900, keep descending, Amiki 6 nautical miles, Zurich 9 nautical miles, Zurich 701, 6 nautical miles, 6,000 Alpha, 180 knots, TRA over here, CI 14, 6 nautical miles, 184,000, make a left turn for a line with the runway. Also the ILS localizer here is Milan City of the airport, 5 nautical miles, 174,000, runway 14, 8 nautical miles over here, 141,430, 1 nautical mile the runway. So we set flaps for landing 15 degrees, center of gravity 23%, 4.25 degrees, and takeoff V1, rerotate to V2, this runway. And we have also departure arrivals, alternate VNAV, progress of sea, communication, hold, route, legs. We can hold over a waypoint over here, fix, and fix. Also use the navigation radio for the instrument landing system of the airport, ILS localizer. We can do that, all for NADFs. So you can see now the flight plan is displayed here in the navigation display. We have also flight director need to be on, LNAV, you can set the LNAV not right now. So we have a bit different display. You can see the flight plan over here in the navigation display just before going into flight. We have the runway here we're gonna use for takeoff, the taxiway and the other runway. Also the terrain in front of you when you're flying, red, green and amber terrain elevation, the range right now. So you see one waypoint by another is from takeoff over here, climb, cruise, descent, approach, landing. If we look further away, we can see more runways, more airports actually further away. Also the center display. You can also see the elevation we're gonna be flying, the vertical flight plan. So we have also the plan display over here. You can see the flight plan in a better view. More airports like the DL over here, Germany, France, down here, Switzerland. So we have the flight plan. See map centering. We're gonna use the ILS localizer for landing, so you can see better view of the flight plan right now. We're gonna be flying through these waypoints we can follow from the LNAV. So we need to make a few more settings over here. Just before going to take off, we need to set up the flight management computer. We did it already. We need to set the overhead panel, the settings, autopilot, flight director system panel, so you're gonna see the airspeed set. We have the LNAV now connected. We can connect also the VNAV, flight director off. It turns off LNAV and VNAV. Autopilot disengage. Climb continues, auto throttle, flight level change. The airspeed here. You can set the airspeed as you can see. Turning these switch. Heading over here, bank angle, roll, limit, and heading. We're gonna set the heading of the runway. 136 degrees over here. Also the altitude of flying 35,000. You can set even higher than that. So we set 35,300, and vertical speed over here, flight path angle. So you have zeros, you can descend like this, and you can also climb the aircraft. You see the plus for a climb. So this is the autopilot setting before takeoff. We need only to set up the overhead panel. So we have the APU. We need to start the APU in the electric panel. Battery, left and right IDG, the great drive generator, left and right engine, 120 200 volts, 400 Hz frequency, 120,000 kilovolts. Electric panel of the aircraft. Primary flight control computers in the auto position. Heading reference flight control surfaces over here. Air data computers over here. IRS. The battery here, towing power. FD door over here. Passenger oxygen over here. Window sheet over here. Rammer turbine. And hydraulics in the off position. We see the fault displayed if we use the off position, so we turn back on, then to the auto, primary demand, and we have the electric already on. So we have the wing and engine guides here on or auto, and also we have here the recorders. We have the cargo and APU fire, the electronic engine control for the engines over here with the auto start that controls also the fatigue, so we can start like this the engines. We can dump some fuel to lose weight in flight if we want to make an emergency landing, and arm this switch and select the nozzles and how much fuel to remain. We can use left and right wing fuel tanks, center tanks. Crossfeed valve can feed either engine with other pump or either tank and balance the fuel between the left and the right wing tank. So crossfeed off, we see the valve displayed. So we have also pressurizer, I explained you from the engine, so from the APU, cabin pressurization with an engine RDIs over here, hydraulic fluid tanks pressurization, also oxygen in flight, so we have pressurization. We see outflow valves in the manual, climb and descend like this, using the auto. So we see also the pressurization of that mentioned here in the screen, pressurization in the manual, then to the auto like this. So we have a couple more minutes. So you see pressurization, we climb to like 40,000, 43,000 feet. We can have a cabin altitude 6, 7 or 8,000 feet, and a differential pressure 78.8 to 8 psi, landing altitude, rate of climb descent, outflow valves in the manual, open climb, gross weight, total fuel on board, and the fuel temperature. We need to recirculate the fuel in flight because it's going to freeze automatically from the fatigue, so go back. Over here, open also these controls, the lighting of the aircraft. So one more minute to start the engine. So we start the systems here display, digital display. You see hydraulics fluid, the APU is running over here, temperature, oxygen, liquid cooling. We have the electrics over here. You see left and right at 120 200 volts, 400 Hz frequency, 120,000 kilovolts. The APU is running. load set in the battery voltages over here, main battery and APU battery and the arborets. So we have the drive contactors, hydraulics, where hydraulic fluid goes, with systems use hydraulic fluids like the flaps, thrust reversers. We have primary demand, throttle valves, electric C1 and C2 isolation valves for an emergency also, quantity of hydraulic fluid and the pressurization of each system 5100 psi. So we go very quickly. Fuel, left and right wing, fuel tank 11,000, 11,000, 30% and 10% in the center, 11,000, total 33,800. So we have low and high pressure fuel valves, left and right engine, open and feed both engines. You see the green lines from the center of the wing tanks. The crossfeed valve is off, but we will turn it on. You can feed either engine with other pump or either tank. Also the APU is fed from the DC motor over here from the main left main tank. We can use also the crossfeed valve to feed to balance the fuel between the left and the right wing. Also we recirculate the fuel from the wing tanks to the engines to heat up the fuel in flight, because as you can see down here we have the minimum fuel temperature in flight is minus 37 degrees. The fuel will freeze in flight and minus 6 degrees. So we recirculate the fuel automatically from the farex, also the lubricant and the oil. We have the air pressurizer regulating temperatures and oxygen. Doors are closed, cabin can be pressurized. The air pressure of the tires and temperature of the brakes. Flight controls over here. This is the flight control deflections. Last thing to do before starting the engines. The tail also, and the stabilizer trim. So last thing before starting the engines, flight controls, deflections. We have also FS display over here, maintenance over here, and circuit breakers over here. So we go back, systems, checklist over here, normal menu, before start, after takeoff, what to do, normal checklist. We go back to the navigation display. So we need to turn off the engines like this. You can see what happens. So both fuel control in the off position. We have fuel starvation right now, as you can see, both engines and the message, fuel pumps forward and aft. So we look outside, we will see the aircraft. We have only pressurized air. We have actually no fuel right now, fuel starvation. So we need to start over here on the auto start in the overhead panel. So we go in here very quickly, both auto start in the on like this in the start. Left and right, you see the yellow reconfiguration amber color in the switches for starting the engines. So we have pressurizer only from the APU admitted into the engines and two stage. So above 20% we can start the fuel flow. So we have 22, and so we have pressurizer right now. So we can start the fuel flow here, fuel control, both in the on position. So we have the auto start is kicking in. Auto start on, 30%, 35, 49, 50 over here. You see all the systems are coming back from the aircraft. And we're gonna have running engines above 61% like this. So we're gonna go for takeoff, flaps up, speed brakes over here up, parking brakes off, advance the thrust levers, and going to the runway. We take the clearance from the air traffic control. So we align here with the runway center line like this using the tiller. You can see. So this is the alignment here. Advance the thrust levers all the way up. Takeoff power and set flaps for takeoff. So we press the yoke down for takeoff. Align with the rudder pedals also. 100 knots over here. So we have 100, 120, V1, we rotate like 9 degrees, pitch up over here, so we pitch 9 degrees or less the aircraft, and we climb. We have takeoff, positive rate and gear up over here, as you can see. So we have gear up, and we have a few more minutes to go for landing. As you can see, we're climbing, so we see so we are 2000 feet above the ground, 2200, 300, 400, but 3900 above the sea. We climb 4000 feet per minute. Air speed 170 knots, the amber and red indication here, the stall speed and the wind direction speed. Also we are having the intercept first waypoint flight plan over here, the engines indication. You can see the autopilot also. So we have also, we are 3000 feet, 3500, you can see that how many thousand feet and hundreds of feet we are above the ground. This green indication is the ground below you, 4000 feet right now, and also around you can see the terrain. Also if we look a little bit further, you can see more terrain with red, green and yellow indication here in the horizontal, vertical. So we're going back for the turn over here. Gonna start turning. The airport over here, the runways, the lakes over here. So we have start the turn. It took a lot of time talking for the systems, so we make a swift turn. Use a little bit left rudder pedal to make it a little bit faster if we need. So we align now with the rudder pedals also as we turn. So we can leave the hands off the flight controls, no problem. Keep climbing. And we have 10 more minutes to go for landing, approximately. So we have a beautiful view here outside, as you can see. Hope you like it. The Swiss Alps. Also another aircraft over here, a couple more as we make the turn. Hope you like the view here, overflying Switzerland, Swiss Alps, the Germany in front of us, the France this way. Hope you like the view of the cockpit as we climb. Of the Boeing 787 jet aircraft. So we need to cross through all these waypoints, and we have 16 more minutes to go for landing. So we make a small right turn over here. Sixteen more minutes. So you can see the airspeed, very important here, 167 knots, the stall speed, red and yellow, the flaps limit, wind direction, next waypoint, Zui, it's like 3.1 nautical miles from us, climb 18,000 feet, 1,700 per minute. Also line here with the flight directors, with the flight plan. So make one small turn over here. So we capture the next waypoint, the Negria, in a couple of minutes. We overflying this waypoint, the Zui, as you can see here. Zui 6000, Negria 25.3 nautical miles. So the Negria is in front of us, the next waypoint. We have to be overflying. As you can see, both sides are indicating the same. Also the autopilot, director system panel. So we're gonna start the turn in a couple of minutes. So we overflying here, as you can see. The Germany over here in front of us, the lakes, the Bayern Munich, my homeland, Germany. Also the France. So we start the turn back to the airport. So we make a small turn, and we have 14 more minutes left for the flight. So we use the rudder pedals again for turn. So we see here as we turn, very beautiful turn over here, overflying France, Germany, the lake, Bayern Munich over here. And the Boeing 787 900 jet model. So we take the turn online with the flight plan over here, make the turn. We can use the override, and we have 12 more minutes to go to the next, to the Zui again. Override the Zui, flying over. So you can override actually one waypoint over here. So we keep climbing. I will show you in a couple of seconds. So we're leveling off here in this altitude, and we have the chemtrails right now. So we have a few more minutes to go back home. We can view this beautiful view over here. I'm flying manually. Overflying also the lake here, Germany, France. So hope you like the view, beautiful star sign over here. So we need to start the descent now. We set flaps up over here and start the descent rate. Idle thrust over here will help us descend faster. We are 35,300 feet. Speed brakes down. Initiate the descent. We can use diverse over here. So we have Nigra. Look at this Zui over here. TRA ZH701. If we activate autopilot, but we don't need right now. Going back for landing. So we use TRA instead of Zui and execute. So we have this waypoint left, descend over here now. Keep descending. Idle thrust. And we have 8 more minutes. Go for landing. We can use also autopilot flight directory if we need any minute, but it's gonna slow down my computer, so I don't need it right now. So we diverted waypoint. You can see the view from here, from the cockpit, Boeing 787. Hope you like. As we are descending. We have also the runway somewhere here behind us. So we can start the descent now, the turn, also as we descending. So here we make a turn, as you can see. A bit more rudder pedal, increase the rate of descent. So this is the turn, keep descending, and also make an approach landing over here as we are descending. We're gonna approach the runway. Increase the rate of descent here. So we have 6 more minutes for the approach and landing. We need to align now with the heading of the runway over here for approach, and also keep increasing the rate of descent. And here maybe down. It's gonna slow us down a little bit. So align here is a little bit rather for alignment. We need a little bit more turn over here. Just a little bit more thrust, engine power. And we have a few more minutes left for approach and landing. Use some flaps over here. Align, we have some wind gusts over here. So we need also the outside view of the aircraft for approach and landing over here. We're going to be having nice approach and landing view. So we are approaching the runway. Use full flaps, idle thrust. Also you can see the runway displayed here. Use a little bit more thrust over here for approach, and flaps also, more flaps. So we align with the runway heading. We have also the Lszh localizer over here. You can see the Lszh localizer information as we are approaching the airport, the runway. So we have quite 4 minutes more for approach and landing. No problem with the time. We will be there in time for approach and landing. So we only need to align now with the rudder pedals. For we having some side wing, as you can see as we are approaching. Also use the head-up display over here. You can see the airspeed, the altitude we are, all settings. So we are aligned, very nice, very beautiful alignment, very professional. Use a little bit less maybe thrust over here as we are descending. Align with the rudder pedals. We have some wind, side wind component and some wind cast. So we align with the control wheel, ailerons and spoilers, and also rudder pedals. Align with the center line, also with the lights and the Lszh localizer. So we are fully aligned, very beautiful approach for the flare now. The flare touchdown over here. So this is the flare of the aircraft, very beautiful. Idle thrust over here, as you can see. So thrust idle, and touchdown. So very beautiful touchdown over here. So we use idle thrust over here and parking brakes for alignment. So we made a full stop landing over here, slowing down, as you can see. 80, 60, 50 nautical miles. So we made a very beautiful over here, slow down. Very beautiful landing, very professional. As you can see, full thrust reverse, and we're slowing down in the end of the runway, last exit over here from the runway. So we made a very beautiful landing. You can see the thrust reverser over here. We can disarm the thrust reverse like this. You can see how we arm thrust reverse. Also you see the reverse in the display over here. One more lesson. Reverse engine over here. So you see all landing gear part over here. It's very beautiful, safe. There is no breakage of any part. The aircraft is starting up the way it should be. The nose wheels, the landing gear behind it. All parts are safe over here for another flight of the aircraft. I can fly one more time. You can see again thrust reverse.